it's got to say the time.
Oh, okay. Is it on?
Yeah.
Okay.
Alright, for group 11, I'm Juan.
I'm Logan. I'm Landon.
I'm Jordan, and this is Reshaping Tech Supply Chain Association merchandise. This brings us to the define phase, the problem statement being that TSCA merchandise from the previous 5 years did not achieve fundraising goals due to high cost, lack of local relevance, and long lead times. The goal is to develop affordable TSCA merchandise that is timely, locally inspired, locally manufactured, resonates with the TTU community, and profitable. The scope being that the project scope is to lower costs on the aspects of labor, materials, equipment, and transportation, as well as improve efficiency through transportation time, manufacturing time for the Texas Tech Supply Chain Association. Stakeholders are TSCA, Texas Tech Makerspace, Texas Tech Student Body, TSCA officers, local Lubbock material suppliers, and on-campus TSCA retailers. This is our project charter. Our sidewalk includes Bowers Plastics, Plains Cotton Growers, and the Texas Tech Makerspace as the suppliers. Our inputs being local Lubbock fabrics, plastics, cotton, and other materials. We also have student-led manufacturing labor. The process will be that we source local Lubbock materials from local suppliers, transport those materials to TSCA manufacturing areas like the Makerspace. We use our TSCA members to manufacture. Then we have our TSCA executive team and administration perform quality checks. They also will then send finished goods to on-campus retailers for student body purchases. The output would be new and improved merchandise, the customers being the Texas Tech community members like students, alumni, faculty and staff, parents, and Lubbock locals. Voice of the customer. So we will be surveying Texas Tech community members on the types of products they would prefer from TSCA in order to better accommodate the wants of our customers and increase sales. This survey will be conducted on our customers, like the Texas Tech community members. The data needed from this survey will be consumer preferences on products and materials from TSCA merchandise. The analytics will be analyzed through Qualtrics software and allow us to determine percentages on each consumer's preference. This will define for us what products and materials we will consume and produce in order to please our target market. This is our critical to quality tree. You can see improved profitability from merchandise sales will derive from reduced cost, change product list to manufacturer needs and to customer needs, and improve lead times in manufacturing process. These things will derive from local suppliers decreasing materials at least 5%, student-led manufacturing saving labor costs by 50%, survey of a diverse body of Texas Tech community members, suppliers decreasing transportation times by 25%, and complete majority of manufacturing in-house to have control over manufacturing times and product availability.
Next is the measure phase. The purpose of this is to validate and quantify current processes, to analyze, benchmark, and solve for improvement. And for our data collection, we gather information from past merchandise initiatives to understand production costs and lead times, as well as sales data. The metrics for this, the lead time, it's time for the ideation of finished product, cost of production, expenses related to design, prototyping, and manufacturing. Customer satisfaction, survey students for preferences regarding style, type, and price of desired merchandise, as well as the affordability threshold, which will identify the maximum price point that students are willing to pay for TSCA merchandise. This is our process map. So to start, we'd source from local materials such as Bowers Plastic and other Lubbock suppliers, Plains Cotton Growers, and Texas Tech Makerspace. We transport it to the site, so we have those materials to work with for our free student labor, and we manufacture it with student labor through TSCA because we were trying to save money. We quality check it, make sure that it's up to quality and that it's not a bad product, And then for the poorly manufactured merchandise, we get rid of it, recycle it, or just give it away, or go back and improve upon it. And if it does pass the quality checks, then we put it into our sales. If they don't sell, it's going to stay in storage, or we're just going to give away for free for very active TSCA members. And then the products that we do sell for the Texas Tech community will be used by TSCA. Our operational definitions, we want to reduce costs by at least 5% on materials and 50% on labor. That's why we want to use Texas Tech students. We want to decrease the lead times by 25% and align product types with student preferences to improve profitability. Operational definitions, lead time from time to order to final product availability, product costs, the total costs incurred while doing this, including materials, labor, and transportation, and finally, customer satisfaction, student feedback on product desirability and affordability. Our data collection plan, we're going to measure lead times, production costs, customer preferences, and maximum price threshold. We're going to ask for former financial records for cost data obtained by TSCA, as well as survey data preferences and how long the process map takes. Data collection led by TSCA team and project members, and for the ongoing product cycles are the who and the when, and the survey conducted across the sample across Texas Tech community members is included in that as well. Our sampling plan, it's going to be at Texas Tech. Sampling will be conducted shortly before Christmas break, and then sampling method will be single random sampling, and we have 150 data points. For our baseline metric collection, these are the results. For a keychain, we got 40 responses, bookmark 15, 3D printed logo 27, and then TSCA fidget toy 46 responses, and then for other products people want, we got 21 responses. For our lead times, the keychain by hand, crafting a simple keychain should only take about under an hour, depending on the design and the complexity of it. For the 3D printer, it's about an hour or two, but it'll be much more sturdy and a lot more usable. Bookmark by hand, about 30 minutes, depending on type of material, and then 3D printer, 45 to an hour, depending on how well we want it designed. The fidget toy, by hand, about 2 hours. It's metal, lots of rivets, lots of mechanical components in it, and then 3D printed 3 to 8 hours because of how complex it is. And then other ideas like t-shirts, about an hour, 2 hours, and then you can't really 3D print a t-shirt. And then key consideration, batch production, making items in batches, post-processing, if 3D printing is used, additional time will definitely be needed. And then material prep, preparing raw materials, plastic, cottons, setting up printer, that all takes time. The key metrics, the median price for 50 items was about $250, and the lead time was about 20 business days for those. Median total time to produce those 50 items, about 50 hours by hand, about 125 by 3D printer. And then the median total price to produce 50 items by hand is about $250, and by 3D printer is about $500. Next is our analyze phase.
All right, so the analyze phase, we want to identify the root causes and use some different analysis tools to look into them. So really what we're going to look into is our high costs. We're going to identify the factors driving production costs. We're going to look into the long lead times, analyze delays in design or prototyping and manufacturing, determine why previous products such as metal trucks and t-shirts failed to resonate. And then our analysis tools we're going to use, the failure mode and effect analysis, and a fishbone diagram. All right. So first we need to identify and theory test. So our first CTQ is to reduce costs by 5% on materials and 50% on labor. So that comes down to material sourcing. By sourcing locally from suppliers like Bowers Plastics and Plains Cotton Growers, Texas Tech, and the Texas Tech Makerspace, costs can be minimalized by reducing transportation and potentially lowering material costs. Conducting a comparison between costs of sourcing materials locally versus outside the area would identify the cost savings. The other part is production volume. Higher volume manufacturing will bring cost savings to your economics of scale. If you plan to increase the volume of merchandise production, this would lower the per unit cost, both for materials and labor. We can test this by increasing the batch size for certain merchandise items and then see the per unit cost decrease. All right, the next CTQ is to decrease lead times by 25%. So first, material availability. Time to source materials can affect lead time. Using local suppliers should reduce transportation delays. And then we can track how long it takes to receive materials from local Lubbock suppliers versus other suppliers, and then compare those delivery times. And then transportation time itself, time it takes to deliver products to on-campus retailers is a key factor. Focusing on efficient logistics will be crucial in meeting the lead time target. Measure the time and distance it takes from the product to reach Texas Tech from its final production process. All right, and then CTQ3, align product types with student preferences to improve profitability. So we have our survey data, voice of the customer. The results of the customer survey will be a direct driver in determining which products resonate with the student body. Understanding preferences for product style, material, and price is vital. The results of your customer survey will be direct driver of determining which products resonate with the local student body. And understanding preferences, product style, materials, and price. Then the next part is design and prototyping process. The process of designing products to reflect student desires and feedback will be crucial. The speed at which prototypes are created, evaluated, and redefined will influence both cost and lead time. Measure the time, or we need to measure the time taken to go from design to final product and assess whether the design allows or aligns with the customer feedback. All right, so then this is the fishbone analysis. So we start with the materials. We have higher prices for material, or higher prices for local materials. That would obviously be a problem. And then also sourcing delays are being a major problem. Then under the methods, we have transportation logistics, which goes back to the long lead times, and then complex manufacturing, which also contributes to the long lead times. And then I also have an environment, so like commodity price fluctuation, obviously like cotton, it's a fluctuating price in the commodities market, so that will definitely influence price. And then seasonal demand fluctuation, that obviously will also contribute to that. And then management, you have insufficient data for analysis, making the managers making it a lot harder for the managers to gauge the market and what people actually want. And then ineffective scheduling, that'd be during the manufacturing process. If there's like delays or back orders, insufficient scheduling can exacerbate that problem. All right, and this is the failure mode and effect analysis. So for the processes, I have material sourcing, production and transportation, market research, or two market researches. One is poor product alignment and the other is poor survey response rate. So under material sourcing, we have high material costs, increased production costs leading to lower profit margins, and then we have obviously the 9 out of 10, and then potential causes of the failure: sourcing materials from high cost suppliers, inefficient transportation. So obviously, like the American-made products and materials are probably going to cost more than the cheaper international ones. So this could be a major risk. And so then we have the RPN of 315. And then we go to production transportation, long lead times, delays in product availability leading to missed sales and lower consumer satisfaction. We have the severity of 8, And then the potential cause of the failure, inefficient logistics, delays in material delivery, and slow manufacturing cycles. And then we have the RPN of this at 384. And then we have our market research. The first, poor product alignment, low sales due to the merchandise not matching student preferences. We have this as a 10 for severity. And then the impact of inefficient market research, poor survey response rate is the cause of failure. And then we have this as a risk of 420, RPN 420. And then the last one, poor survey response rate, insufficient data to accurately predict product preferences. Give this as a 6. And then lack of engagement, poor survey design, or low response rates. This all adds up, or multiplies up to be the RPN of 384. So we have our biggest risk being poor student product alignment, but that also directly relates to the market research, which is a 384, along with the product and transportation. So our lowest RPN is our material sourcing. All right, and now we have the improve phase.
Some alternative ways to run the process. Some other ways that have been discussed to run the process are process mapping, Kaizen, and benchmarking. Process mapping will allow us to visualize and understand what we're doing at a certain point in the production timeline. Kaizen, we will use this in order to achieve continual improvement of the production process. Benchmarking would allow us to compare our production process to other manufacturing companies making similar products. All these are alternative ways to run a production process in a different way that may allow us to manufacture our products quicker and of a higher quality. The best alternative method to our projects is the process mapping method. This method will allow us to mark our progress using increments of completion while at the same time being able to see the bigger picture and goal of a completed project. By utilizing the processing mapping method, we'll be able to see the full picture of what we're trying to create with our product. Potential risks. There are a few potential risks that might be incurred. These include an oversimplification of a plan. By being oversimplified, there's a risk that our process map might inaccurately present the actual process of us, resulting in incomplete assessments or misunderstandings. An overcomplication of the map. By having a highly complex process map, our ability to understand the map and or act upon the map in the first place might become difficult for us. An over-reliance on the process map. By having a process map is a valuable tool, but an over-reliance would only be detrimental towards the success of our project. Our pilot test will be production of a small batch of 5 3D printed logos. First, we will run a week-long test to see what the reaction from our customers will be like. We will then perform KPIs in order to receive customer satisfaction through a survey. We will then collect feedback from the result of our survey and analyze the results. We will distribute our products to our potential customers and collect data on their opinions of the product. And finally, we will use the data we collected to determine if we need to make any modifications to the product or our service. We will then write a report about the results of our pilot test. Now on to control.
Control phase. To restate the objective, it was to sustain the improvements in the production, cost efficiency, and the quality of TSCA merchandise, ensuring future profitability and alignment with Texas Tech community needs. The previous processes included outsourced production with high cost and long lead times, limited alignment with local relevance and community preferences. Our revised processes include local sourcing of materials and student-led manufacturing at Texas Tech Makerspace, and the integration of iterative prototyping and community feedback to refine designs. And we project to see the outcomes such as like the previous high cost, long lead times, and low sales due to misaligned products offerings. The change would impact it to be reduced production costs by 5%, increase lead times by 25%, and increase customer satisfaction based on survey results. The benefits would be reduced material and labor costs led to an average savings of $3,000 per merchandise cycle. And we got improved profitability from higher sales due to better product market alignment. This is the storyboard. So we generate ideas, we source the local materials, prototype it at the makerspace. We send out a survey, get community feedback. If we get bad feedback, we revise the prototype. If not, we start manufacturing, we go to quality checks. And if the quality checks come out bad, we revise manufacturing. And after everything's like good, we distribute to campus retailers. Okay, so the control plan, the KPIB, we have material sourcing and cost from local suppliers, efficiency and reliability of 3D printing processes, quality standards for prototyping and final productions. The KPOV includes product quality, pass/fail rates, and quality checks, lead times for production and delivery, customer satisfaction support. Our response/reaction plan is production delays, use real-time tracking to identify bottlenecks and resolve supply chain disruptions, quality failures, implement retraining, and stricter quality checks for prototypes and final products, and low sales feedback, which we reevaluate designs and pricing based on post-sale survey results. In continuation, our monitor and control pan, we track lead times, costs, and quality metrics monthly to ensure continued performance improvements, conduct biannual reviews with the TSCA executive team to evaluate progress against key goals. Our verification method would include compare monthly metrics to initial targets, example cost savings, lead time reductions, and customer satisfaction improvements, and conduct process audits quarterly. Our new process integration would include implementing detailed production workflows for all TSCA merchandise and establish partnerships with local suppliers for consistent material availability. Our processes include the procedures and training that we have to do. So we have to create a step-by-step guide for merchandise production and quality checks, train new TSCA officers and revise processes, focusing on prototyping, manufacturing, and community engagement. Our audit plan, we plan on conducting quarterly audits of production, costs, and customer feedback metrics, document the findings, and recommend actions for improvement. Our sign project, ensure the project or champion endorses the final report to confirm compliance with project goals and sustainable practices. For the ownership, agreement with new owners, formalize agreements with the new TSCA officers to ensure adherence to improved processes. Training for new owners, provide hands-on training sessions for new officers to ensure they understand each step of the revived process. Our transition plan includes implement a transition timeline to ensure continuity in merchandise production and overlap outgoing and incoming officers for knowledge transfer. The key takeaways include importance of aligning merchandise offering with community preferences, the value of local sourcing and in-house manufacturing for cost and quality control, which leads to further opportunities such as exploring collaboration with Texas Tech alumni for co-branded merchandise, expand product offerings to include seasonal or event-specific items, and leverage data analytics for deeper insights into community preferences and sale pattern. And that's it.
All right, thank you.
Thank you. I'm just doing that for editing purposes.
Oh, did you read it?
Some alternative ways to run the process. Some other ways that have been discussed to run the process are process mapping, Kaizen, and benchmarking. Process mapping will allow us to visualize and understand what we're doing at a certain point in the production timeline. Kaizen, we will use this in order to achieve continual improvement of the production process. Benchmarking would allow us to compare our production process to other manufacturing companies making similar products. All these are alternative ways to run a production process in a different way that may allow us to manufacture our products quicker and of a higher quality. The best alternative method to our projects is the process mapping method. This method will allow us to mark our progress using increments of completion while at the same time being able to see the bigger picture and goal of a completed project. By utilizing the processing mapping method, we'll be able to see the full picture of what we're trying to create with our product. Potential risks. There are a few potential risks that might be incurred. These include an oversimplification of a plan. By being oversimplified, there is a risk that our process map might inaccurately present the actual process of us, resulting in incomplete assessments or misunderstandings. An overcomplication of the map. By having a highly complex process map, our ability to understand the map and or act upon the map in the first place might become difficult for us. An over-reliance on the process map. By having a process map is a valuable tool, but an over-reliance on one would only be detrimental towards the success of our project. Our pilot test will be production of a small batch of 5 3D printed logos. First, we will run a week-long test to see what the reaction from our customers will be like. We will then perform KPIs in order to receive customer satisfaction through a survey. We will then collect feedback from the result of our survey and analyze the results. We will distribute our products to our potential customers and collect data on their opinions of the product. And finally, we will use the data we collected to determine if we need to make any modifications to the product or our service. We will then write a report about the results of our pilot test. Now on to control.